Record to the cloud. I think it's supposed to be recording. Welcome everyone to the new Falco Community call. We didn't have calls in the past 2 or 3 weeks, I don't remember. And we don't have extremely big updates because, everyone is on vacation, everyone is on quarantine and everything, but the community is going on. We are having news. We will have great news in the next few months. The next week, there's KubeCon and many Falco maintainers and users have talks there. So it's those are difficult moments, but Falco as a project is going and growing strongly as always. If you didn't do it yet, please add your names to the who joined. I'm calling specifically Spencer out because he's the only one who didn't. If anyone else wants to give Spencer a favor because he's on the iPad and can add Spencer's name on the document, it would be very helpful. As I said, we don't have highlights this week, but we have an agenda, which is at this point, it's only stuff from me, but if you want to add anything, feel free. I am doing some work around Userspace. If there's someone who doesn't know, Userspace instrumentation for Falco has been added in Falco 0.24.0. Specifically is the -u flag that we added to Falco. So if you start Falco with the U flag, it will not look for the kernel module or the BPF probe, but it will just start and read the memory area from where it can get events. This is, just a very basic highlight. As a service to the Falco community, I put together a repository, which I should be linking in the document, that contains, so it's here. I will add a link in the document. The repository contains a very simple implementation of a Userspace. Let me stop it a second. Of a Userspace implementation for the SCAP protocol, which is, since Falco is based on SysDig, it's still implemented in SysDig. We are figuring out how to put it out. But
so the protocol is a name now, the SCAP protocol.
Yeah, I call it SCAP protocol. If you don't like it, do you like it? I don't know.
No, yeah, it's fine. Yeah, it's fine. I was just smiling.
Okay. Yeah, Loris invented it and he didn't give it a name. So after working, some hours on it, I just had to name things. As the repo is showing, you basically start SysDig or Falco, with the U flag, like I'm doing here. And once, in this case, Falco is started, I am now starting, and I'm just building the example. And once it's built, just give myself of 2 weeks ago time to build this thing. Once the stuff is built, this thing can be just used to send an event to Falco. So if you see my screen here, I'm just calling Userspace example and sending a fake event to Falco. This is not just for sending fake events, as you probably Userspace example, as you probably understand. We also have already a working implementation in the Falco security organization of something that uses this protocol to send events from real system events, and it is PDIG, the Falco security PDIG repository. So if you download PDIG, compile it, and then execute a process by using PDIG as a wrapper or attach PDIG to a process ID, you will receive those events without the need of the kernel driver or the BPF probe. And this new protocol opens, a lot, a set of, enormous possibilities to the Falco project, because you can now, before you were very tied to the SysDig code base to do anything. Right now you can just, implement the protocol like it is implemented in this repo. So you can look at the repo for reference. and input events to Falco in the way you want. I also started myself a little POC experiment to input events to Falco using BCC. For those who doesn't know, BCC is the BPF compiler collection. So it's just it's a lot of tools that lets you create a BPF program in an easier way. And the BPF implementation that Falco uses is not using BCC, and by not using it, it's much faster and much more powerful. But it requires the fact that that implementation requires you to use the specific implementation for BPF that it's in SysDict. While if you use BCC or take another BPF implementation and attach it to the BPF, to the Userspace API, you can create something that uses BCC and the Userspace API to put data into Falco from Userspace. And that's what I'm doing in this Falco BCC repository, which I'm gonna publish soon. So it's basically just a BPF program that does on syscall enter and on syscall exit, which I didn't finish yet. So you can see all the registers being passed to a queue. But the real interesting things is that I read all the events, I take them, and then I call this fire event function, which sends everything to the Userspace, protocol implementation that then service everything to SysDict. I will publish the code here, very soon, like today or early tomorrow. Just for reference, it's not in production ready, but it showed me already very interesting insights, and I'm going to show you this now. So again, I'm starting SysDict because Falco, I didn't port this to Falco yet. But if so this is going to break very soon. I mean, it's going to break in 1 second when I start, but it's going to show events, hopefully. So I do Falco BCC, and I put my password wrong. And, oh, only one, great. Let me use them on the Falco B. Sudo, okay. Okay, I add some events, and then I add some errors. I need to figure out all these, all the events I have to ignore, all the memory that I'm not checking and everything. But the difference between this and what we have now is that I'm using a BPF, but I didn't need to provide a pre-built BPF probe. I didn't need to provide anything. I just had my program here, I just started it, and it works.
So, Lorenzo, let me recap what's happening here.
Very messy.
No, just to make sure I understand. So, first of all, the first piece of context is there's this new flag in both SysDict and Falco called -u,
yes,
which essentially makes SysDict and Falco receive events not from the kernel module that we install in the operating system, but from a shared memory buffer where processes or applications can essentially write events, and Falco will be able to consume them. Exactly. And that's the user level protocol. That's been introduced recently.
This is the shared memory buffer Loris is talking about.
This shared memory buffer and this mechanism to send data to Falco has been introduced recently because in particular, is tied to the work that we're doing to support event capture in Falco in environments like Fargate or like wherever, where essentially you don't have access to the kernel of the operating system. You cannot put anything in the kernel. You took this mechanism, you sort of reverse engineer the protocol behind this mechanism, and you wrote a new implementation of kernel level system call capture that is based on using BCC in a separate process, injecting something in the kernel, and taking this information, putting it in the -u shared memory buffer, and magically on the other side, it's still crashing a little bit, but magically on the other side, essentially Falco or sysdig in this case are seeing these events. So you sort of re-implemented a new version of Falco kernel instrumentation by using BCC in a separate project that is at this point completely detached, and this Falco is receiving events even if there's no kernel module running at all on this machine. Am I getting this right? Do I have all of these different
Everything
pieces
is
right?
completely in place. Yes.
So now,
so I misused the new Userspace implementation because it's supposed to be for Userspace stuff, but I use it for kernel space stuff. But
yeah,
it works.
Now, my question is: this implementation, is it just an experiment, or there are benefits by doing it with BCC the way you're doing? You are mentioning, for example, kernel headers. Can you clarify a little bit? And yeah, and if yes, just in a general way, understanding why potentially we would go for such an approach based on BCC compared to maybe what we already have with eBPF.
I don't think that the BCC approach, that the BCC specifically, is better than the BPF implementation that we have.
The BPF implementation that we have is not based on BCC. So it just, how does it like produce the BPF code that goes in the kernel?
There are, you can use the, you can implement. Okay, there's the BPF syscall, you call it, and when you call it, you load the program that you compiled, which is falco.o. You compile falco.o, and you load it with the BPF
that
syscall.
when we compile Falco for a machine.
Exactly. Normally, users, they use the Docker image, which if they enable BPF, it will compile that code and put the O file in a place. So when Falco starts, it can go and take the O file.
Okay, essentially the Falco container starts.
Yes.
The Falco container contains the source code of our existing, let's call it legacy, eBPF kernel instrumentation.
Yeah.
The Falco container starts, takes that code, compiles it, and then uses the eBPF system call to inject it into the kernel.
Yeah, exactly.
And compiles it how?
It compiles it using Clang.
So it's not BCC, it's Clang.
Exactly.
Okay, and BCC is a completely different compiler?
No, BCC is the same compilers. The difference is that BCC compiles it at runtime in the way I implemented it. So when you start this program, it compiles internally because it has all the compile function it needs to compile internally, so I don't need to provide it in advance. And BCC provides a lot of high-level helpers, so that when you do a mistake, you see, you are missing a pointer, or you're missing, instead of seeing the machine code. Well, sometimes if BCC is broken, or if you did something very bad, you always see the machine code, but it's more rare. But I don't think that the advantage here is only using BCC. I mean, BCC is useful, but the advantage here is that we are detaching the BPF implementation from Falco. So we could even use our own BPF implementation and input the data in this way. But it's an idea that I only had now and I didn't do it. And it will be the same. The only difference is that we will need to provide the O file because we don't have a mechanism in Falco to compile internally. Well, we could copy it from BCC, for example, But I think that this is the two things. So having the compilation internally and doing the separate process is the nice thing, because in this way you can reduce the surface of attack of Falco, because you don't have to give Falco permanent BPF capability and other capability that it needs to do it.
Plus, I imagine, for example, I mean, we started this project and this user level protocol because we want to support environments like where you have very small containers like Fargate, for example. And in that case, you could really decouple. Falco could really become really tiny because it could really only have the logic for the reception of this data. And could be really a super small executable. And then you could have this external module that you could put on the same container, but potentially, ideally, this could even be, it's decoupled, so it could even be remote, right? So in theory, you could have this little capture component only in a container, and then you could have the Falco logic decoupled and somewhere else, and the two could talk together through a protocol that is not a shared buffer, but something else.
Like,
right?
Like what you're saying is, if Falco BCC, for something like Falco BCC, would expose like an HTTP API,
or it's
or
unique
whatever,
socket,
a unique
yes,
socket, to anything over network, an IFINet interface, where it receives from that TCP IP interface or whatever it is, and writes to the local buffer. Yes, it's a possibility. So you just implement basically, never higher level API on top of that API, and then you can do whatever you want in the cloud native environments that connects using sockets instead of shared memory buffers.
Then if we extend this, and again, I'm doing science fiction here, but just for the sake of the discussion, if we extend this, we could have potentially a single Falco, because this mechanism allows potentially multiple producers. So we could have a single Falco, maybe listening to the data coming from processes, coming from different containers that are, in an orchestrated kind of setup, and then put all of the data together. So you could have a single Falco engine, essentially supporting multiple instrumentations and consolidated the data. So you could have a relatively light footprint, even in situations where you have a very high container density and places where it's hard to maybe put something in every single container.
Yeah, it's very possible, because the events are very lightweight. I mean, this is an event, right? So just...
Could you make the font a little bigger?
Yeah. It's okay, everyone?
Yeah.
So this is an event. So just a new int64 containing pointers and pointer references. And I mean, the fire event function is just a wrapper that I put around the protocol because it needed so many things to do for me. But this is just what it's needed to do. So this is mocking a rename at syscall. If you do man rename at, it will need, the first argument is the file descriptor of the directory of origin. The argument 2 is the file descriptor of the directory of destination, and the old path and the new path, and then it's just a rename. So yes, it's very lightweight and extremely, I mean, maybe it's not extremely portable, but you can figure it out. I mean, these kind of things. I mean, you maybe don't want to use the same Falco for 2T system with different architectures. But that's just
in theory, and then I will shut up. But in theory, Falco, the producer will abstract it, because
maybe
no, wait, no, because you receive system calls, yes. Right? So
you need, in the producer, you need to go and look up the generic.
yes.
And then
So
from the generic.
different architectures might be a trouble. Yeah.
The problem is that we work on syscalls. For everyone who might not be into this, and syscalls have specific numbers on different architectures. So we need a way to, Falco has a way inside where it transforms the specific number to, a generic number. So the producer will need to be aware of this when they are doing operations. Like this NR rename at is different if you are compiling this on a x86 or on a PowerPC 64, and it's just that. So the receiver must be the same architecture to work on it, or do wrappers on top of that. Okay, so I think I said everything I know. I will take care of sharing everything I do in this direction, maybe a blog post or something, probably a blog post.
Yeah, it would be nice to get a blog post, definitely. These are, from one point of view, experiments that can be just considered fun experiments, but there are also there are elements here that could guide the future architectural decisions and directions of the tool, especially when looking into supporting new modern environments. So having these written up, documented, and maybe advertised a little bit with the blog post could be interesting for the community for sure. It would be interesting for me. Maybe it's just because I'm a system call nerd.
The idea initially was just to do an experiment. However, by working on it, I noticed that this is so flexible. I mean, I've been able to debug. I opened GDB on Sysdig, I opened GDB on Falco BCC, and I was able to debug the BPF program, Falco BCC, and Sysdig all together while working, which is the first time I'm able to do it. And in the past, I was struggling when we had bugs, when we had problems into doing this, just because there was no way to jump from one thing to the other because everything was loaded underneath. And so I think that this is possibly the future. I mean, passing everything to the user space, the SCAP API. However, I don't know. I mean, I just have too many segfaults now for making this decision. But when the segfaults will be ended, probably. So thanks, Loris, for your feedback. Need help updating the drivers?
Sorry for jeopardizing the conversation.
Well, you didn't really jeopardize. There are only my points. Can I ask Spencer to go after me so that I don't talk for 2 hours alone?
Sure thing, homie.
Thank you, Spencer. Do you want to talk about the Python client?
Sure. I mean, there's not a huge update there. I dropped a couple links in the Slack yesterday. The Python client didn't get updated for the gRPC changes that we dropped recently, or not even that recently. I think they went out with 0.240. Anyway, it took me a while to kind of wrap my head around it, but
okay, it's still open. You need the reviews?
There's some reviews. It was quiet for a long time, but Mattia showed up to help out. So I think most of the reviews he's got at this point are like, I think it's a he. Sort of move this data around or whatever. It's not like it doesn't work.
Thank you for your effort.
Yeah, and then there's a couple, it immediately became useful because I wrote a 10-line program to connect to gRPC socket using Python and then dump it straight into log DNA, right? So it's like perfect. So that's just kind of cool.
Yeah, that's useful. Did you put it here or it's?
It's in my. I'll put it somewhere.
It's hidden. Okay, understood.
I'll throw it somewhere. I'll throw it in the Slack. It's just I'm gonna throw it in evolution. I just it's not quite clean enough yet, but
Thank you. Yeah, many people are asking for that kind of things.
Sorry, can you just clarify a little bit for me what this little Python program does? It consumes Falco events and it acts as a bridge to log DNA. Is that right?
Yeah. So I just dropped the link. You can click it if you want, Laura. Yeah,
oh, yeah,
that's all it does.
Great. I think. Thank you. It's not the malware, right? Joking.
Are you piping it to bash?
Yeah. Should I?
Always.
Oh yeah, MAC address. Okay, cool. Oh, okay.
Yeah, well, there's some requirements that, like any log aggregator, right? You have to fill out some things that they insist need to be on every log line, which
so
isn't
neat.
always accurate.
Just wow.
Yeah. Well, this is why I started that conversation with Thomas yesterday, is because, so how is this actually working is there's a little there, it's implemented as, I guess you could call it a first class citizen or whatever under Python logging. So it's just Python logging that goes to log DNA. And they actually made it threaded. So it batches them up every second and then submits it as a blob, which is kind of cool.
Very nice.
And so I was asking Thomas, like, well, does the Sidekick let you do that? Because this is the kind of thing you could do with the gRPC socket, but not with like the Sidekick. So I think so. It's kind of cool.
Yeah, we probably need at some point to, see if Thomas is willing to compare, or at least add an option to Sidekick to use gRPC instead of standard output.
Yeah.
Because it's
anyways, that's it. Just kind of
thanks for the example, because this is this is very useful for people to just go and see that it's very easy and doesn't require them to.
Exactly. These 60 lines of code immediately clarify, essentially, at least for me, what this does and the power of this. To the point that, again, potentially it would be nice to have a short blog post that just highlights this, and we could put it on the Falco blog, because it's very nice.
Yeah, for sure. Happy to help.
So you also support the output format and everything. Very cool. I mean, I love it. Thanks.
Very, very nice.
Sharing.
Thanks, guys.
It's me again. Okay, I need some help updating the drivers. In reality, I already have. Oh my gosh. I already have this patch containing all the new drivers that we need for new Amazon Linux or new CentOS and everything. This will need to be applied to the test infra repo. So for those who doesn't know, test infra contains a driver kit folder, which contains a config. This is the SHASM of every driver that we support right now. This is the latest one. And for every driver that we have, we have a YAML file. The YAML file is containing the kernel version and the path where this should go. So basically, this is what builds the pre-built driver for us, and it's awesome. Sorry, my son is screaming. This is what allows us to just, when people start Falco, if they cannot compile the module, they can just, go grab it from our artifact server. But this requires, some effort. Sometimes we just need to update everything because AWS releases new Amazon Linux, CentOS releases new versions, Ubuntu releases new updates and everything. The problem is that since the other maintainer of these is on vacation, and maybe people are opening issues, I cannot approve my stuff. So I will need someone who's willing to receive the patch from me and open the pull request so that I can review it and approve it. Which is, or someone who is willing to just be added here and help us, which is equally good so that I can send the PR and get the approval. So if anyone wants to step in and be into this stuff, it will be very good. Test infra is not just for this. Test infra is also for, we have a Kubernetes cluster where all this stuff runs. We have our bot, which is, go and comment the issues and pull requests. And we have some services that are running for Falco as a product. So if anyone wants to help on this, just reach out in Slack or raise your hand. Oh, again, test infra, good news. AWS approved a lot of money for us actually for doing our Kubernetes cluster on AWS. They reached out to us, 1 or 2 months ago, because the software that you use, which is Prow, which is the same that Kubernetes community uses, is not very well integrated with the actual infrastructure that we use, which is the CNCF cluster, which is on Packet. The problem of that is that Packet doesn't provide many high-level features like, an S3 and, other things that we need. Another problem is that, the Falco maintainers team is not a, team of SREs, so we don't want to maintain a Kubernetes cluster on Packet. So having a software that maintains everything for us, like KKS or whatever, KS with, the name of the company as first letter, is very good for us, so that we don't have to, update Kubernetes, make Kubernetes up and running every week, and make it secure and everything. That's it. So AWS reached out 10 or 5 calls ago. We decided to go with them and let them, ask credits for us, and now we have the credits. So we have those 12Ks. We can use them. We will also create new dashboards for contributors because we can use the S3 of Prow. So we will be able to enable plugins that will help us doing dashboards and everything. I know that this stuff might be, just who cares about this, but I just want to show a link to everyone for what I mean. So this is the Kubernetes test infra, which is very similar to what we have. And the kind of dashboards that we want to start enabling are these kind of dashboards, right? So we want to be able to have integration dashboard for our integration tests, where we can see the matrix grid of everything that was put together, like with different versions of Kubernetes, with different versions of the dependencies, these kind of things. And we want to be able to see, failures aggregated in this way, and many other things that we could use, but cannot use now because we don't have persistence, because S3 is not impacted. So there's some work to do in that direction. The first thing is to migrate what we have, which is very easy, because you just have to start a Kubernetes cluster and qctl apply stuff, because we don't have any state right now. And then, do work and enable everything else. That's it. Anyone is interested in helping? Again, you always know where to find me. If there are any questions, I'm here to answer them. Yeah, running an open source project is a lot of fun. You now have to maintain a Kubernetes cluster too. And that's it. I mean,
so some people have fun maintaining Kubernetes clusters.
Yeah, there are some.
Fairly classic. Fairly classic, yeah.
Spencer probably wants to help with maintaining a cluster, right, Spencer?
Yeah, I mean, I have to be sensitive of how much time I have. Obviously, I'm down to help.
I know.
It's like, I do this a lot where I say I'll do shit and then I don't. So I try to be sensitive not to bite off more than I can really chew.
I think you should send a pull request here to add your name here, so that we can use your name as approver for this repo, Spencer. Honestly.
Thomas did the same thing on the Sidekick like earlier this week or last week or something. So it's, okay.
No, don't feel forced. I mean, only if you want.
I do have if you're okay with new business, I do have a generic question.
Tell me.
when I was working on the Python client for gRPC, you know, what's our answer on the Unix socket itself? Because it gets created 700 root. But if you're just reading a stupid Python program or the Falco exporter, you don't really want to run that as root.
Yeah.
I mean, or do it. I don't know.
So my question is there any requirement of protecting the socket from anybody reading the information? These are Falco alerts. So is it a problem if a process with arbitrary user ID consumes the data?
I don't think so, honestly.
If not,
Well, kind of, because it's not. Remember, it's
yeah,
like you only get one shot to pull it out. So you.
Oh, right, it's true.
So it's not like.
Plus,
and that's that's a different conversation.
It could contain
about many read,
sensitive
right?
information, right?
But
in theory, a Falco alert could contain sensitive information that you might not want somebody to read, right?
so I'm so happy that they implemented it using root permissions now.
No, I was asking because if we don't worry about who receives the data, you just open it more broadly. But because yes, having to be root just to be able to consume the data might not be good. Otherwise, we need to implement some kind of protocol, right?
Or just maybe in packaging, you install a Falco Unix group. I don't know if we install a Falco user, Falco Unix group.
Yeah, like Docker
and we
does.
could group the Unix socket, right?
Yes.
And then if you put the user in group, I mean, that's how Docker does it, right?
That's probably, I also was doing the same thing because the Userspace protocol we were been talking about before does, a file on the file system so that you can just, write to it or read from it. And that has the same problems, right? Because you need to decide who can write and read from that file. And I was thinking about the same. So probably, yes, this is a good idea. So, and also it's it's relatively easy because it's just a setup problem and can be written in documentation, principally, probably, if I'm not wrong. But the problem is that we will need to ask system maintainers to create a user for Falco, which will need basically just root, like Docker does. So, yeah,
yeah, I don't know, something to noodle on. Yeah,
but at that point, you start the Python client in this case, and you need to start that with that user, right? And once you start that with that user, you are basically root. Because, it's the same with Docker and then people start, adding their users to the Docker group. So I don't know. I will be very happy to continue having this conversation and, see it implemented also because if you had this question and you are a very restricted group of people, imagine when, broader users start using it. So I think it's something that we should do. Did you already open an issue, Spencer, about this?
No, I wasn't sure where on the working as intended to, we hadn't thought about that spectrum we were.
I think it's a Falco repo.
Yeah, okay, I can open an issue, no problem.
Only if you want, as always, if you have time, I can do it for you if you don't have time, no worries.
I'll do it, no problem.
But yes, it's a very good question. How do we do it right now with everything else? Because we also write outputs to files. I don't know, honestly, it's a question that I don't know the answer.
But outputs to files are written by Falco, right?
Yes, so it's root.
So if you run Falco as root, it's root. Yeah.
Mm-hmm.
I don't think there's anything done to those files, so they're just open.
Yeah, I just want to
regularly
avoid that
by a root process.
I just want to avoid that we have already something in place that we are not considering, but probably not. Yeah, surely not. I didn't see anything like that, but who knows? Thanks, Spencer, for bringing this up. Oh, you already did it?
That's what we're doing, and maybe that's because syslog's doing it. So then yeah.
So that's the same permissions probably. Okay, should we add a note? Yeah, exactly. Thank you. So there's anything else? I don't have any other points myself, but we still have time, if I'm not wrong. We can discuss other things.
Not for me.
Netch, do you have anything you want to tell us?
No, just here to get the latest update on Falco.
Okay, thank you. Yeah, permissions. Yeah, permissions are just, gosh, just hard to handle. What's the UMask? I don't remember what's the UMask too in Falco, but whatever. Okay. Okay, so if we don't have anything else, I will just wrap up and talk about the release. We have a release next week, and I'm going to be probably the only maintainer available because everyone else, after coming from the vacation, is
on the
going
beach
to be for KubeCon. So the release is scheduled for the 18th. I mean, that like could be the 17th or the 18th or the 19th. I mean, it's flexible, but probably on the 18th. And to do the release, we need 2 approvers. So it could be a problem for me because I don't have approvers to the Falco security repo. So I will need to figure this out.
Do you want to just push it? I mean, it seems probably better to push it than.
Yeah, maybe, but we committed to time-based releases, and I always say to push them. I maybe could push it 1 week if everyone agrees, and so that I don't have to do strange things to the approvers file and to the infrastructure just to do the release myself. Also because I don't want to take full responsibility for the release, even if it's very small, because one time I did it and it was a complete disaster. So yeah, it's not a very big release if we want to go through it a bit since we have time. So we decided to push it 1 week, right? Everyone agrees?
Yeah. Let's do it.
Okay, I'll send an email about that. So Laura.
If somebody had a problem, they should have come to the meeting.
Exactly.
Amen.
A week later to let better plan. My strange English strikes again. So the release still has 7 things open that we can put to the other release because, as I said, we commit to time-based release and not feature-based release. So we just push things back if they don't match our timing. We have some pull requests and some issues to look at. And basically what goes to this release is print version startup, libyaml in bundle depths. This one is was very annoying because no new systems have libyaml in their packages. So many users are reporting that they cannot install libyaml, so they cannot use Falco. Right now, after this release, libyaml will be bundled into Falco as a static library. Some improvement to the integration tests and some rule updates. So it's a very small release. So pushing it 1 week, it's okay. And then this is a very big change. I don't know if we will be able, thanks Ricky for streaming, to get this done, this week. I think this is probably the most important thing that we have here. So the support for PowerPC 64 is, we already discussed this in the community call, is just blocked by the fact that, how to say,
it's like a multiple different Luas, right?
Yeah, there's it's also not this pull request, it's another one, but whatever, I just explained. We have Lua JIT, and there's Moon JIT, and there's Raptor JIT for Lua. Not all of them work in all of the architectures. So we need to find one which is, very good at working in multiple architectures and very good at, doing what we need. Otherwise, we can, just create compile time constraints to, use one or the other or whatever. But we need to get into that so that we can start making Falco work on PowerPC, which apparently is a very, common use case. And that's it. The other thing on that is that at that point, we will need to have a PowerPC machine in our test fleet so that we can make sure that we don't break that when we do things. And that's it. So
I can probably help with that.
Yeah, thank you. That would be very useful. I think that Travis CI does have PowerPC, but we switch it to Circle CI. But we are also migrating to the AWS cluster. But we have many things. We can use whatever we want, but we just need to have these machining, because it's very easy in Falco, since it's a very low-level tool, to break support for one architecture that we had, and that's why right now we are just advertising Falco for x86. It's because everyone works on x86, but if we are able to be very reliable for PowerPC, ARM, and other architectures, the project will benefit, and will also show that we have reached a maturity as a project, and we can put also these as an argument for graduation, because it's a very good argument in my opinion. That's it. Any questions? Anything else? Do we just want to stop the recording and hang out? Yes.
Thanks for running the meeting.
Thank you.
Yeah, thank you.
Let me stop recording. Yeah, I want to stop the recording.